Hi, hello, very good evening, one and all. Welcome to the most comprehensive preparation app for all exams, BYJU'S Exam Prep. This is Satya Narayana, waiting for you all to join the session. Today, we will quickly revise all important formulae of my subjects, which are very useful for your BARC exam, which is just 4 days away from today. So before I start, I want every one of you to please join the session quickly and mark your presence. Manishankar, good evening. Those who have joined the session, kindly invite your friends for the session. This is a quick introduction about me. You can find my details here. And before I start, currently there is a September month sale going on online classroom program. That is, you can get now flat 25% off on this online classroom program. To avail this offer, use the code extra25. Don't forget to use this code extra25 and take this online classroom program. Okay. Shivani Gupta, good evening. Now, guys, if I need to start, I want everybody to please share this session information as much as possible. Okay, now firstly, to start with, programming and data structures. From this subject, what are important formulae or important points you have to revise without fail is, firstly, if you take arrays concept, before arrays, let me talk in this way. Data types, we know there are fundamental or primary data types, char, int, float and void. These four are said to be primary or basic data types. For char, you can apply either signed or unsigned type qualifier. For int, you can apply either signed or unsigned or short or long. For float, you can apply signed, unsigned and long type qualifiers. Now, for any data type, if n bits is the size, if it is signed type qualifier, then the range will be -2 raised to n minus 1 to +2 raised to n minus 1 minus 1. If it is unsigned type qualifier, then the range would be 0 to 2 raised to n minus 1. Now, either it is a signed char or unsigned char, the size is 1 byte. Integer size is compiler dependent. It may vary in this way. It may be 2 bytes or 4 bytes or 8 bytes accordingly based on the compiler. float size is 4 bytes. And what is double? Long float is what we say double, whose size is 8 bytes. And long double means 10 bytes. So this is the first point about data types everyone has to recall or remember. Then operator precedence and associativity is the next important point. Operator precedence and associativity. There is a big table. To remember this table easily, I generally give this code, that is, please remember the code UASRBLTA. UASRBLTA. U for unary operators, A for arithmetic operators, S for shift operators, R for relational, B for bitwise, L for logical, T for ternary, A for assignment. Unary operators have the associativity right to left. Ternary has the associativity right to left. Assignment has the associativity right to left. All the other are having the associativity left to right. So at least this code will help you to remember the operator precedence associativity in simple way. Okay, this is the second point. Then about arrays. In arrays, what you have to remember, arrays and pointers together, what you have to remember is, let A be the array name, P be pointer. Okay, then always remember A of I is equal to I of A, that is equal to P of I, that is equal to I of P. What you will get? Value. This is for one-dimensional array. Similarly, A plus I, that is always equals to P plus I, that will give address of A of I. Okay, if you take two-dimensional array, for 2D array it is different. How? A plus I will always give address of A of I, in the sense address of ith row, address of ith row. Then star of A plus I gives what? This also gives you address of A of I. That means this also will give address of ith row. Star A plus I plus J, what this will give? Address of A of ith row jth column element. Address of ith row jth column element. And star of A plus I plus J will give A of ij, that is value. So with respect to arrays and pointers, this is what very important you have to remember. Okay, then when we talk about data structures, in data structures especially trees has more formulae. What are the formulae we have to remember or revise? First I can say, in a perfect binary tree at level L, number of nodes will be 2 raised to L. Numbering always starts with 0. Okay, and if there are in a binary tree, if there are X leaf nodes, suppose there are X leaf nodes, then number of nodes with exactly 2 children will be X minus 1 in any binary tree. This is the second point you have to remember. And third point is, for a binary tree with height h, you are given height h, then minimum number of nodes will be h plus 1, maximum number of nodes will be 2 power h plus 1 minus 1. This is the third formula important to remember. And one second, let me add one more slide. Suppose instead of height you are given, for a binary tree with n nodes, total there are n nodes, then maximum height possible will be n minus 1, and minimum height possible will be log n plus 1 base 2 minus 1. This is next formula from trees data structures, which is important to remember. And next point is the number of, hello Bharat, the number of unlabeled binary trees with n nodes, that should be 2n cn by n plus 1. If we want labeled binary trees, the number of labeled binary trees with n nodes, that is 2n cn by n plus 1 into n factorial. These 6 important formula you have to remember, which will help you in your BARC exam from programming and data structures. Okay, next, if we switch to algorithms, from this algorithm subject, undoubtedly what is important means master theorem is very, very important. master theorem is very, very important. So what is master theorem? We have master theorem for decreasing function, linear decrease and exponential decrease. So if your recurrence relation is of this form, then we will analyze the relation between a and b to the power k with the subcases. Accordingly, we can directly write the time complexity of this recurrence relation. Similarly, if the recurrence relation is of this form, a into t of n minus b plus f of n, then based on a value, you can write the time complexity of it. It is advised everybody to learn this master theorem because it is very, very important, most expected in the competitive exams like BARC, ISRO, even GATE also. GATE, NEELIT. Okay. So please learn this master theorem. It saves a lot of time in the exam. Alright. Now, before I proceed, I request everybody, those whoever are watching, to kindly share this session information as much as possible. Invite your friends to the session. Next, from the algorithms, the next important thing you have to revise is sorting algorithms time complexity. Majorly, you have to learn 6 sorting algorithms. 6 sorting algorithms. What are they? Bubble sort, insertion sort, selection sort, quick sort, merge sort, heap sort. Majorly you have to remember best case, average case, worst case, time complexities. Bubble sort, best time complexity you can say as big O of n. Insertion sort you can take n square. Selection sort you can take n square. Quick sort you can take n log n. Merge sort n log n. Heap sort n log n. Merge sort, heap sort are having same time complexity in all the cases, that is n log n. Quick sort will have n log n complexity in average case also, but in worst case it will have n square time complexity, and all the other are having n square time complexity. So guys, from algorithms, sorting algorithms time complexity, better you revise once before you go for the exam. Okay. Then other algorithms time complexities, like suppose dynamic programming based applications. If you want to remember, mainly you remember matrix chain multiplication, time complexity is n cube. Then Bellman-Ford algorithm, time complexity is n cube. Then Flood-Warshall algorithm, time complexity also n cube. And divide and conquer algorithms, if you want to remember, majorly Strassen's matrix multiplication, if you take, its time complexity is big O of n to the power 2.81. Towers of Hanoi, big O of 2 power n. Merge sort, just now I told you, big O of n log n. Quick sort, big O of n log n. Divide and conquer applications. Similarly, 0-1 knapsack problem, you may take, that is big O of n into, we can say knapsack weight into number of items. Okay, like this, job sequencing with deadlines. Yes guys, are you following? Could you please respond to me? Everybody, kindly respond. All right. Okay. Yeah. So greedy algorithm, job sequencing with deadlines, if you take n square. Like this algorithms, when you are preparing, please prepare the time complexities and master theorem without fail. Okay. Then moving on to operating systems. First, CPU scheduling is very important topic, which is very easy topic also. From this, if you want, first turnaround time formula. Turnaround time formula is completion time minus arrival time. And what is waiting time formula? Turnaround time minus burst time. These two are very important, which will help you while calculating average turnaround time, average waiting time, or respective process turnaround time or waiting time. Okay. And then with deadlocks, if there are m resources, n processes, then with how many resources deadlock will not occur? For that we have two formulae. Sigma of all the resource requirements should be less than m plus n, or m should be greater than or equal to sigma of every process resource requirement minus 1 plus 1. Okay, this is very important from deadlock's point of view. Then from operating systems, page tables is very important concept. Always remember, number of page tables will be equal to number of processes. for single level page table. If you are using one level page table, then every process will maintain its own page table, and number of page table entries will be equal to number of pages per process. And how do you calculate number of pages per process? Number of pages will be equal to process size divided by page size. Then you will get number of pages. And virtual address is always composition of page number, page offset. Physical address is always composition of what? Frame number, frame offset. Okay. And if you use segmentation, then segment number, segment offset accordingly. Okay. Then from computer networks, first and foremost, OSI model is very important. I think everybody know OSI model with 7 layers, layer 7 to layer 1. Application layer, presentation layer, session layer, transport layer, network layer, data link layer, and physical layer. These layers have their own terminologies. At application layer, we can call the data as message. Presentation layer, PPDU, presentation protocol data unit, session protocol data unit. Transport layer data you can call as segment. Network layer you can call as datagram or packet. Data link layer you can call as frame, and physical layer content you can call as bit. So this layer terminology is very important, and the responsibilities or functionalities of each layer is also very important. Then we have types of delays in computer network communication. Among them, transmission delay. How do you calculate transmission delay? Message size or packet size by bandwidth. And how do you calculate propagation delay? Length of the channel divided by speed of propagation. And for half duplex communication, transmission delay will be 2 times of propagation delay. You can take like this. And for full duplex communication, 1 time of propagation delay. This will be applicable for CSMA by CD or Ethernet networks. This into 2 will be applicable. Right? So this is very important. And then give me a moment, I am taking one more slide. Good evening, Janak. IP addressing is very important, guys, in computer networks. Those 5 classes and their range and private addresses, CIDR addressing, supernet addressing, subnet mask, you have to recall all those. So class A range is 0.0.0.1 to 127.255.255.255. Class B range would be 128 to 191. Class C 192 to 223. Class D 224 to 239. And class E 240 to 255. First and last addresses are reserved. First is always for the network interface, last is always used for broadcast addressing. Along with this, you also recall private IP addresses range, how we calculate CIDR addresses, subnet mask. Please recall all these without fail. Okay. Then Janak, I am trying to provide important points for the subjects I teach. I teach only 5 subjects, but still I try to provide, if possible, in the Telegram group. I'll try. Okay. And from computer organization and architecture, guys, majorly what you have to remember, first of all, this cache memory. This is very important topic from computer organization and architecture subject. From cache memory, mapping techniques. We have direct mapping, associative mapping, set associative mapping, right? In the direct mapping technique, how the address is interpreted as tag, line offset, word offset. If it is associative, tag and word offset. Set associative, tag, set offset, word offset. This is how the interpretation of the address in these 3 mapped cache. This is first important thing from the cache memory topic. Then what is maintained as a tag? If it is a direct mapped cache, main memory page number is maintained as tag. If it is associative, main memory block number is maintained as tag. If SAM, only MSB bits of main memory block number maintained as tag. And if we take conflict misses, in direct mapping they are very high. In associative mapping they are 0. In set associative mapping they are less. And if you take hit latency, in direct mapping it is very less. In associative mapping it is very high. And in set associative mapping it is less. So cache memory mapping techniques related consolidated information, you please prepare like this if you have not prepared yet, and please revise without fail. Okay. Then from secondary memory, hard disk related, one formula is very important. That is, if CHS is given, if CHS is given, cylinder number, head number, sector number are given to you, then how do you calculate the consolidated sector number? That is C into total number of surfaces into number of sectors per track plus H into number of sectors per track plus S. This is how you will calculate the consolidated sector number if CHS is given. Okay. And as BARC don't have NEAT type of questions, if you are given this sector number and if you are asked for CHS, please use the formula in the reverse way on the options. Which option gives you the given sector number, that is the answer. Simple. Understood? Then always remember instruction pipelining topic also. Always revise instruction pipelining topic also. In the instruction pipelining, suppose you are having uniform stage delay. Then how do you calculate pipelined time? N plus K minus 1 into small t. Non-pipelined time, N into K into small t. If you are having non-uniform stage delay, then how do you calculate? Using space-time chart, you will calculate this non-uniform pipelined time, and summation of all the times will give you non-pipelined time. And suppose if you are having stall cycles, then how do you calculate pipelined time? Effective stall cycles means 1 plus stall cycles frequency into number of stalls into cycle time. This is how you calculate. And how do you calculate speed up? Always non-pipelined time divided by pipelined time. And suppose if you are given the stage delay, the stage time as a combination of stage delay and interstage delay, let me call this as TD, this as TI. Then for pipelining, how do you calculate the stage time? Max of stage delay plus 1 time of interstage delay. For non-pipeline, summation of all the stage delays. Okay, so this is how you calculate the stage time. And if you are given CPI, then in terms of CPI, if you want, it is cycles per instruction into cycle time. And cycle time is always inversely proportional to frequency. Okay, so this is how you should have a short notes already by this time, like how I have revised very quickly 5 subjects most important points or formulae. In the same way, your short notes should be in such a way that in max 2 hours all the syllabus you should be able to revise. So that is what the short notes usage, so that you will remember all important formulae without forgetting, without confusion. Okay, I hope this session helped you out. And guys, I think you people might know admit card for the BARC exam is out, I think. So please download your admit card. Also, to strengthen your preparation, on Sunday and on Monday, Sunday and Monday, we are doing a marathon. Sunday, that is 19th September at 8 p.m. and Monday also 20th September at 8 p.m. on YouTube. We are doing a marathon classes for BARC aspirants. So without fail, try to attend these sessions. Prepare well. Prepare means you just have more 3 days. How to utilize these last 5 days, I have done a session yesterday. If you have missed it, please go and watch it without fail. All the very best, guys. See you in the next class. Till then, take care. All the very best. Bye-bye.